All right. Thanks a lot. Yeah. Here I am. As has been said, I'm Tabitha Sable, and I want to share something with you today that I really love, which is vulnerability scanning. Now, it's kind of unusual for anybody to say that they love vulnerability scanning. People often are much more likely to hate it or think that it's a just a problem. But I have been a person who runs production infrastructure and does hacks for years and years and years. And so doing both of those things at the same time means that I often end up spending a lot of time helping those two groups work together, the ops folks and the security folks. And spending time in both of those worlds has really given me an experience of vulnerability scanning that has led me to really love it. Um, it's probably a compliance requirement. You're gonna have to do it anyway, so you might as well make it fun and useful. And that's what I would like to share here today. So got some goals here. I really want to share the joy of wandering through your network and jiggling all the door handles to see which ones might be left unlocked. Encourage collaboration between the different groups that get involved in this, because blue team has something to do with it, governance, risk, and compliance has something to do with it, sysadmins and ops folks, DevOps, developers have something to do with it, and occasionally even offensive security. And I'd just like to share some of the pitfalls and how to avoid them that people often run into. So to be a little more specific about what's going on, want to be clear about what the topics are today. So I'm going to be talking about network vulnerability scanning, which is using the tools that will crawl through your network and talk to all the services that seem to be listening there and try to determine whether they're vulnerable to certain things. There are a lot of other types of tools that also fall under the vulnerability scanning umbrella, but we're not going to be talking about automatic source code scanning, fuzzing of applications looking for crashes, artifact scanning like container image scanning with Claire or Trivy. We're not going to be talking about the sort of magic that GitHub can do when it can tell you that your project is depending on these other libraries that have vulnerabilities in them. We're just going to be talking about the thing that x-rays your network. So we'll just get right into it. First, we'll be talking about, why do we care at all? What's in it for us? What are we going to gain? And then we'll work through the things that we need to know to be able to really make good use of network vulnerability scanning, how to understand the findings that are on the report, validate that those findings are actually legitimate and apply to your environment, evaluate what those findings mean within the context of your environment, and then some thoughts about how to do the remediations in a way that'll help everybody. So what are we here for? Everybody has something to gain from a good vulnerability scanning program. On the defense side, it can free up time to work on other things that are more sophisticated or more interesting, because once you have a good system up and running, it will in some ways take care of itself. On the ops side, you can get some change control improvements, because oftentimes the worst vulnerability scanning results come from the sort of servers that time forgot, that fell off of the fell off of the change control map and have just been running there without anybody paying attention to them. And vulnerability scanning tools can be useful in a first phase of an offensive campaign, like a penetration test, especially when you're in a big hurry and have some initial things that you want to focus on. You can kick off a vulnerability scanning tool and just let it run without paying attention to it. It's slow and loud and overly broad, but that kind of multitasking could save you some time. So to understand the findings, when we're talking about the findings, we're going to talk a lot about exploits. So first we'll talk about the common exploit types, and then we'll go over what you'll see in the output of a vulnerability scanner. So software isn't perfect, it has bugs in it, and some of those bugs can have a security impact. So there's a good scientific breakdown of the various sorts of bugs that can have security impact in the Common Weakness Enumeration project, but I haven't seen a similar scientific breakdown of exploit types. So I've developed these 4 categories of exploit types just based on what I've seen and the sorts of things that I have done in my career. And when I say exploit, I really mean any action that you take on a system that results in behavior that is unexpected by the designers of that system. So sort of the headline exploit type is remote code execution. An example of that is the famous Eternal Blue vulnerability that was in older Windows versions, where you could send a magic packet to the SMB1 port and run code. And remote code execution basically means I can do anything, like your computer is my computer now. Um, Slightly less attention gathering, but frequently just as dangerous from a risk management perspective, are authorization or authentication bypass exploits. An example of that is the famous dirty cow exploit against Linux that allowed you to bypass file permissions and do other sorts of shenanigans because of a kernel bug. In essence, authorization or authentication bypass bugs are I can do something inappropriately. Next, you have information disclosure bugs, which are essentially I can learn something inappropriately. A few years ago, Heartbleed was a famous information disclosure bug in OpenSSL that leaked a small number of randomly selected bytes from server memory. And then the last category that I've enumerated here is denial of service attacks or exploits. And those essentially say, I can disrupt you in a way that I shouldn't be able to. And a recent famous example of that is the selective ACK panic bug that was in Linux, where by sending certain packets over the network, you could get the machine to kernel panic. So those are the sorts of exploits that we're going to hear about in the vulnerability scanner findings. So in a vulnerability scanner output, like either the web UI or a PDF or an Excel output from the scanner, you'll typically have these fields: the name of the finding, the host it applies to, the port, if applicable, that it applies to, the common vulnerability scoring system score that is assigned to that vulnerability. This is a attempt to assign a numeric value to how bad vulnerabilities are. And so it goes on a 0 to 10 scale, bigger is worse. It's important not to place too much emphasis on the CVSS values of certain vulnerabilities, but it's certainly better than nothing. Then there will usually be external references, like to the vendor's bug description, to patches, to blog posts and write-ups from researchers. And then there will usually be a little bit of explanation right in the tool as to what the bug is like. So let's look at some examples. Here in the tool from Rapid7 NXpose is a result list screen. Up at the top, we see the host it applies to. And then down in the table below, we see test names and CVSS scores for those results. If we open up one of those results, we get some more detail. Again, from the top going down, we have the test name, host it applies to, a severity word, and a CVSS score. We've got some references here in the form of a CVE ID number. That's a common vulnerability and exposure ID number that you can look up in the National Vulnerability Database. References, explanations, and then down near the bottom is the port that the service was running on that this result applies to. Similarly, here we have the open source vulnerability scanner OpenVAS, and we can see on this the test names, CVSS scores, host IP addresses, and port numbers. And when we drill into one of these results, then we also get explanation and references. Same thing here as Nessus. Up the top, we've got the host, we've got test names and severities, which in this case are just colors and words, but they're related to the CVSS score. And when we drill into the results, we see that same severity, the test name, a nice description, some references, and then down near the bottom, the host and port that this result applies to. So these are what you see on the reports, but the next thing to think about is whether they actually mean anything. So to understand that, we need to get into why network vulnerability scanning has the strengths and limitations it does because of the procedures that it follows. and then talk about how to consider, are you truly vulnerable? And if you are truly vulnerable, is it exploitable in your environment? So the basic procedure for a network vulnerability scanner is first to run a port scan, sometimes by banging out to a tool like Nmap, or other times just using code inside the tool, and enumerate all of the services that are running as configured in the tool. So that may be just the top 100 TCP ports. It may be all 65,000 plus some UDP and some other IP protocols. It may include other things like logging into the host with SSH or WMI to pull patch lists, but you enumerate information about the host. Then you iterate over those discovered services and try to learn more about them. Typically, the goal here is to learn what service it is, like what brand of software it is. If it's a web server, is it IIS or Apache or Nginx, for example? And what version is one of the big targets of information gathering here. Then you compare that information that you've gathered to a large database of vulnerability tests, and for each of those tests, perform the test. So when you're doing that, there's a lot of potential shortcomings. So if the service is misidentified, then that could result in false positive or false negative results, because false negative results could come from a test being run against a service that doesn't apply to it, while other tests that should have been run sit idle because it was misidentified. False positives can also happen if a service is misidentified and then a test that is not particularly picky is run against it. You could think that it's vulnerable to something that doesn't actually apply at all. Also, these tests are software, and so there's the possibility that they're buggy. A lot of the tests, the best tests, will exploit the vulnerability in a harmless way. So they will exercise the software in some way to look for a behavior of the software that's unique to the vulnerable version. Those sorts of tests are great because they don't get fooled by version misdetection, but they're also more complicated and can result in bugs. Um, a third thing that often results in false positives is the backporting of fixes. This happens especially in the enterprise Linux space, where your version of Ubuntu or Red Hat tries to keep the same versions of software for many years, often long after the upstream project has stopped supporting it. And the way that they do that in a relatively safe way is by tracking upstream and backporting fixes for security bugs. So even if a certain version of software is vulnerable and upstream's not supporting it, that old version, when distributed by Ubuntu or SUSE, may be completely safe. So tests that work by exercising the bug will not be fooled, but tests that work just by pulling the version string and comparing it to a database, those are going to have problems. So once you've considered whether or not the vulnerability is actually applies to the software, there's also questions of, is it exploitable? So in many cases, there are bugs in less commonly used features that may be turned off in your environment, or may have to be accessed through a certain interface that you don't allow, or you may have other kinds of compensating controls. Like, for example, if there was a bug relating to sending very large packets, but the switches on your network only allowed normal size packets. So there's these various reasons why, even if you're running the vulnerable code, it may not be exploitable in your environment. And so that can drop the criticality of fixing it for you compared to someone else that had a bigger exposure. And so you need to think about those things. After you've evaluated those, then you can start to think about, what is the actual risk that this vulnerability poses in my environment? And to do that, we'll first talk about what do you do when you're attacking a system? And then you need to think about, what are you protecting? And with those two things in mind, you can start to daydream, how does this vulnerability help my attackers? So when you're trying to attack a system, it's basically the same kind of workflow that you use for any human problem solving. So you may have seen this. There's a trademarked version of it called the cyber kill chain. And in other environments, people may talk about the OODA loop, but this is the way that I think about it. Study the target, plan what you want to do, maybe study some more, exploit something that could get you what you want or not. So you may go back to studying, or you may just achieve your goal. And if you're working on this for a long time and have a long chain of exploited systems that you need to follow through to get to your goal, you may want to plant some malware or do other things to leave a backdoor for yourself. So I think as a flowchart, it's a pretty good thing to visualize. Start up here in the study blocks and sort of enumerate in your mind everything that you know, which at the very beginning may just be an IP address or just a company name. And then move on to the planning phase and think about, based on everything I know, what are all of the possible next actions that I could take? And if you like some of those next actions, think about the ones that are most likely to help you achieve your goals and try one by moving down to the attack something phase. If you don't like any of your next actions, then you can go back from plan to study and study some more, read up on some more techniques, do some open source intelligence research. Eventually, you get an idea for some attack that you want to try. You want to exploit a piece of software, you want to send a phishing email, so you do that. And that may succeed or fail, and in either case, you learn something. So that may put you back to the study phase, or you may get a foothold on some system, so you will optionally persist there, and then you either keep iterating through this study, plan, attack loop until you eventually give up or you achieve your goals and move on to the win. So, got to think about, if that's what a clever attacker is going to do, what are you trying to stop them from getting? And here are some of the concerns that you want to think about. Essentially, your computer systems are valuable. The data in your computer systems are valuable, and they can be used against you in various ways for different reasons. So now think about, how does this vulnerability help my attacker? Somebody who wants to do something bad to me, how could they use this to help advance their goals? Because as a defender, your goal is to stop them. And a great way to do that is to use a tool called attack trees, which are essentially replaying that attacker methodology backwards. Rather than starting with knowing nothing and trying to move toward your goal, you assume you already know quite a lot about the system because you operate it. You know as much as anyone else. And then from that goal, think about all of the last steps that somebody could get to that goal, and then iterate through that, forming a tree where, what could somebody do to get to this? What could somebody do to get to this? Until you get down to the leaf nodes of the tree, which is, what does some attacker that I have considered, what can they do as a first step? So if the attacker that you're thinking of is a random person on the internet, then you keep iterating that tree until you get to something that can be done by a random person on the internet. If the attacker that you're thinking of is a malicious employee, then they have a lot more first steps that are available to them. And so let's draw a couple of example attack trees. So say an attacker wants to steal engineering data. There's a few ways that they could do that. And we won't draw out the entire tree of all possible ways to steal engineering data, but just as an example, you might try to do that by exfiltrating digital records from a file server after pivoting through a multi-tiered network with a DMZ and an inside. And that could all start from a remote code execution vulnerability on a public-facing web server. So If you do this, if you can mitigate that remote code execution vulnerability, then that makes it harder for your attacker to get onto that branch and move up that path toward that goal of stealing engineering data. And so that's a way that this vulnerability could help your attacker and why you might want to cut them off from it. Maybe instead, they would like to infiltrate your customer's network. And there's a lot of ways they could do that. But one possible way would be if they could backdoor your product download by uploading a modified version through your portal. Exploiting an authorization bypass in your application after registering for an account could potentially be a way to do that. They could be registered as an ordinary end user, but by exploiting a bug they've discovered in your software, they could take on a role of your employee and start sending their modified software to your customers in a supply chain attack. So this is how something that is seemingly unrelated, like exploiting an authorization bypass, could end up with, you being in the news. Suppose instead I'm the attacker and I just want to make some money. I want to mine some Monero on a cloud account. I could just pay the cloud provider, but I don't think I'm going to make money at that. And cloud providers usually have pretty solid security, so we're not going to bother drawing that part of the tree. But maybe if I can just borrow somebody else's account, like by logging in through stolen credentials. So phishing is one of the most common threats against organizations today. And your phishing campaign can be a lot more successful if you have a list of all the users. And so that username disclosure vulnerability in your custom web service, it may have a CVSS score of 4, but that doesn't necessarily mean that you want to ignore it. It could be really useful to an attacker as a beginning node in a tech tree such as this one. Then, some people they just want to see the world burn. I just want some lulz. So I want to block your users from being able to access your product. And if there's a really bad performance bug in your code, and I can just run that code a lot by accessing your product, then I can just laugh because I feel good that I have inconvenienced you and your users. So, even something like performance regression can have some security implications as well. So with all of those things in mind, you've got this big report out of your vulnerability scanner, and you can think about the various results that are in it and how they apply to you, and now you need to remediate them. And the two most common things to do are to apply a patch that gets rid of the bug, or apply some kind of configuration change that will mitigate the ability to activate that bug. So, patch it. And this is a real common place where security and operations teams can get along a lot better. There's this sort of nightmare of the security team coming to the ops team, like with a suit and a clipboard, and saying, these are all these bugs, hurry up and fix them. We're going to tell you how to do your jobs. And it doesn't make anybody happy. And so, as a security team, thinking about the fact that this is essentially making more work for the ops team, and trying to work with them to ensure that that work gets done in a way that fits as well as possible into their workflow. Sometimes some vulnerabilities are so severe that you actually do need to drop everything and fix them immediately to the exclusion of all other work. But a lot of vulnerabilities are not nearly so serious. And if you know that you have a robust patching program in place, or you know that you have good monitoring, you can work with the operations folks to come up with a plan to get the thing remediated in a time frame that can make the compliance people feel comfortable, but without ruining the ops people's lives. You know, Similarly, if you're an ops person and you're thinking about these sorts of analyses of the results in the vulnerability scan, that can help to justify in your mind why the security people might have their hair on fire sometimes, and also can help you push back if they have evaluated a vulnerability to be more severe than it really is. Sometimes you can't patch things, but then you can mitigate it. Do whatever you can to reduce the value to the attacker. Maybe a service can't be fixed, but it's on the internet and it really doesn't need to be. You can put in, a firewall or some kind of network control to stop it from being accessible to your attackers. You may be able to make a configuration change. If a security relevant bug is in a feature you're not using, you could turn it off. So, when patching is too difficult or unavailable, think about these utility to attacker concerns and try to devise a mitigation strategy. Sometimes you can't really patch it or mitigate it. You just have to accept it. It never feels good, but that is a part of life. And in the case where you're accepting a risk, it's really important to understand what it is that you're accepting. And this sort of analysis of your vulnerability scanner results can let you feel more confident that the risk that you're accepting is actually acceptable, or get you to push back harder against accepting the risk. So that's what I got. Basically, vulnerability scanning can be really fun and useful. You get to send a lot of weird packets to a lot of hosts on your network, and you get to spend quite a bit of time, thinking about how to be bad, how to do bad things, but all from the comfort and safety of, you know, being on the right side of your users, being on the right side of your org. So remember, it's a really powerful tool, but it does have significant limitations. So you have to be really thoughtful to get the good value out of it. I hope that these thoughts will help you to get started doing that and help you to see and enjoy the fun of it. Did we bring up any questions along the way?
I don't see any questions. Um, oh, I'm sorry, there is a question. So the question is, what tools, free and paid, do you like using?
So within vulnerability scanning, yeah, there's a lot of different tools. Honestly, my favorite vulnerability scanner is OpenVAS, which is free and open source, but can be a challenge to use. If you're using the open source version, there's several different daemons. They all have configuration. They have to be set up properly. On Kali Linux, you can usually just apt install it, and it usually just works, but people sometimes have trouble with that. And if you really want to use it, it does bear studying, because most of the problems that happen with it are relatively simple configuration errors that are impossible to fix if you don't understand the architecture, but fairly simple if you do. There's a commercial version of that as well from Greenbone Networks in Germany, either as a physical appliance or a virtual appliance. I really like it. I like the UI on it. I like the quality of the tests and the fact that you can actually read the source code of the tests, which can be really helpful when you're deciding whether or not you want to believe the results. Um, Nessus, I like the tests being readable in Nessus. I like the quality of the tests in Nessus, but the UI for running the scans, collecting the results, leaves something to be desired, in my opinion. And Rapid7's NXpose, I feel kind of the opposite way about. I like the UI. I think it's wonderful. The tests are usually pretty good, but when you're looking at results and trying to decide whether you really believe them, to me, it's frustrating that you can't read the source code of the tests. They're in a mangled binary format that doesn't really allow introspection. So those are the three that I have the most experience with, and they're all decent.
Awesome, thank you. So we have two more questions.
All right.
So the next question is, would an attack tree be a good starting point for security and DevOps to do prioritizing, FMEA, Ishikawa, or similar, and based on that, mitigation?
110%. In my opinion, that's by far the most scientific way to go about these things. So you have some kind of environment that you're defending. Either it's like a traditional kind of on-prem network with users and services, or maybe you are a service provider, like a cloud SaaS provider or something like that. But whatever it is, you have something that you need to defend. And the best way, in my opinion, to know what it is that you need to do to defend it is start by doing threat modeling against it. Understand where the attack surface is in the network or environment or product you're defending, and then think about doing some attacker stories for who possible threat actors that you need to defend against could be, and then with those capabilities in mind, start to build out attack trees that take you to common goals that could want to be achieved against you, stealing data, modifying your environment, those sorts of things. And with that context built in a shared way between the security team and the ops or engineering teams, then you can really prioritize detections. You can prioritize what you need to remediate when, because you can put a CVSS of 10 in context. A CVSS of 10 is going to be really serious no matter where, but if an attacker has to be buried 7 levels deep in your network to be able to access it, it may not be as much of a hair on fire as it is if it's on the public internet for anyone to exploit.
Great, thank you so much. I really enjoyed your talk. Um, I'm going to take you away from being a presenter. Um, Please feel free to join in on Discord. Thank you so much for presenting today. It was really interesting to listen to.
Thank you so much for having me. I love to share this, and I hope you all have a good day.